Okay, so we are going to look at the binomial distribution, which is a discrete probability distribution. And in our specific example, we're going to look at a binomial distribution which has 10 trials, and the probability of success for each trial is 0.3, 30%, which would then mean the probability of failure is 0.7 or 70%. So in a binomial distribution, here underneath the x column, I have 0 through 10, which is going to represent exactly 0 successes or 10 failures, exactly 1 success, which would be also 9 failures, 2 successes and 8 failures, and then so on down the line. And under our f of x column, we are going to compute the probability of each of these. So the way I can do this is here I'm going to start with the x equals 0, so the probability of 0 successes, and click into this cell. And I'm going to do equals BINOM for binomial dot DIST for distribution, and then open up a parenthesis. And you'll notice that it kind of tells you what needs to be put. There's 4 things that we have to enter in. So the first one, where it says number underscore s, is the number of successes. And since I'm looking at x equals 0, I want 0 successes. But I'm going to actually do something more general so that I can copy and paste and it'll autofill in for the rest of my numbers 1 through 10. So instead of actually entering in 0, I'm going to enter the cell that it's in, which is B5. And then a comma, and then the number of trials, which is 10, and that's in cell B1. And so what I enter is a $B $1, comma, and then next, the next entry is the probability of success. That's what the probability S stands for. And that's in our B2 column. So you can see the B5 blue is highlighting this as the number of successes I want. The red is highlighting this, my number of trials. So the next entry, $B $2, is in purple, which is matching with my probability of success, comma. And then finally, here in this 4th entry, we're going to enter false, which is going to give us the probability there of exactly 0 successes, and then I hit enter. So I get 0.0282 and so on as the probability of 0 successes if each chance has a 0.3 probability and 10 trials. What I can do to check that then, over here next to it, I'm going to do equals. I'm going to calculate this out by hand. So COMBIN is the binomial coefficient, so we're going to compute the binomial coefficient, which we have to, notice it prompts you here, the number, so that's our number of trials. We have 10 trials, and we're choosing 0 of them to be successful. And then we have to multiply that by our success percentage, 0.3, to the power of how many successes we want, which is 0, times our failure rate, 0.7, to the power of how many failures we want, which is 10. If we have 0 successes, we have 10 failures. And I hit enter, and you'll notice those are the same. So instead of doing all these individually, what I'm going to do is click into the cell where I entered kind of the general entry. I'm going to copy that, and then I am going to highlight all of these and then paste. And you'll notice it auto-fills in different numbers computed for exactly 1 success, exactly 2 successes, and so on. And I could check if I wanted to by doing my long way, the computing it out. So COMBIN for computing my binomial coefficient. This time I have 10 trials, but I'm choosing 1 to be successful, times my success rate to how many successes I have, times my failure rate to how many failures I have. And that's the same thing. So I could check these for each of them, but I'm going to trust that my formula was correct here in this first column.